Hello grade 11s. We are going to now talk about something called the quadratic formula, and it's a particularly useful thing in finding the roots of any quadratic equation, and it is made possible by the thing we did in the previous video called completing the square, which may have felt a bit overwhelming at the time. Now, from time to time we do use the completing the square technique, and we are asked to, but most of the time its real cleverness is in the application of the quadratic formula, which we use completing the square to find the formula and know how it works and why it works, but often we can just use the formula. Before we look at what the quadratic formula is and how it helps us to know the roots of quadratic equations, or the solutions we may call them, let's look at just the standard form or different forms that quadratic equations can come in. So I want to suggest that all quadratic equations can be described by a standard form that looks like this: ax squared plus bx plus c, where a, b, and c are constants. So let's look at examples. If I looked at that first example, x squared plus 2x minus 3, I would say that a is 1, I would say that b is 2, and I would say that c is minus 3. It includes the minus. If I then had to look at another example, we would say that in that second example, a is 1. Now what about b? What's b going to be? So b turns out to be 0, and c would be minus 9. So I'm just looking at, essentially it looks something like this: 1x squared, and then I can go plus 0 times x, and then minus 9. And you can see, well, actually, because there is no middle term, then the b must be 0. And then the last one over here, we can look at it and we can say, look, a would be, a would be, in this case, 1, b would be minus 2, and c would be equal to 0. And so we see that the standard form also has everything on one side, and we're kind of used to this from other standard forms before. Okay, so let's work from there. We've got a standard form, and our goal is now to find the roots of any quadratic equation using some sort of method or specific thing that works every time, what we'll call the quadratic formula. And I said finding the formula with help from L. So if we start, we are going to start with, did I write anything down here? I did not. Okay, so we're going to start with the standard form. And if I take the standard form of a quadratic, it looks like this. And I'm going to use the technique of completing the square. Now, when you complete the square, and I didn't really mention this that much in the previous video, but I tried to kind of get it in there with the common factor at the beginning, is that you need to have a coefficient in front of the x squared of 1. And at the moment, the coefficient in front of the x squared is actually just a. So is there a way that we can keep this the same equation, but still have a 1 in front of the x squared? And I want to suggest there is. There's a way by dividing everything by a. So if you divide everything by a on both sides of this equation, it stays the same. So in the first case, what's going to happen is we're going to get a x squared. So divide the first term by a. And then the second term divided by a is just going to be that. And then the next one is going to be that. And then anything divided by 0 turns out to be 0. So even though it's 0 divided by a, it's still 0. Another way of thinking about this is everything gets multiplied by 1 over a, and that will have the same effect. And if you're confused why it's a 1 there, I didn't actually draw the a in there, you can see the two a's would cancel. Okay, so now I've got that. Now, the technique is still very new to you, but the next step would be to move the constant term to the other side to be by itself. So what's the constant term? Well, in this case, the constants are a, b, and c. And so what I'm going to do is the c over a is going to reappear on this side. In reality, what I'm doing is I'm just actually taking away minus c over a from both sides, and in effect that's cancelling the left c over a out of the picture, and it looks like it's just reappearing out of nowhere. Now, what was that clever step with the technique? So we know that we are now going to complete the square on this side. So the whole goal of this process is I complete the square on this side. But it's not a square yet. So I'm going to take these two terms and I'm going to focus in on the second term here. And the key step was I take the coefficient in front of the x and I divide that by 2. And then I square that and then I add that to both sides. So that sounds like a mouthful. What does that mean? Well, dividing by 2 is often easier to see if you think of it as times by a half. So if I think of timesing by a half, b over a, if I times that by half, it just becomes b over 2a. And now, in order to follow the process that I followed earlier, which is probably still a little bit strange to you, I'm going to square that. And if I do it to one side, in order to keep my equation balanced, I do it to the other side. So, now, I have my equation is the same. It looks kind of impressive mathematically, but really all I've done is added the same thing to both sides. And I want to now complete my square. And I also want to clean up the right-hand side. So using the same technique, I know there must be an x here. I also know that I take the sign over here from the middle term above. So that's going to be a plus. And what's going to go in here? Well, it's just going to be b over 2a. And again, I would encourage you to pause the video, multiply this out, even if it looks a bit strange, and check for yourself that this does work. Okay, then on the right-hand side now, it's kind of messy. I want to suggest that when I expand this fraction above here, I'm going to get b squared over 4a, and that's an application of exponents. You know, I'm squaring the top and the bottom. And I want to actually add these fractions together, and I want them to have the same denominator. So how about if I times the top and bottom by the same thing? So I'd have minus 4c here, and then 4a there. So I've times the top and bottom by 4, which is completely fine. So now, if I then take the right-hand side and I clean it up a little bit more, let's have a look. What can I do? So I kind of think the negative should be second, so I'm going to get b squared, and then I'm going to say, oh, actually, what have I left out? Can we spot something I've left out here? 4a, we've got there, b squared, so b squared minus 4c, and now do we have 4a over here? Let's have a look here. Have I missed something? Oh, I know what I've missed. Can you spot it? Have a quick look. I've missed something. So above, oh, I can't believe I did this. When I squared above, it should have been b squared over 4a squared. And when I then needed to make the things the same, I needed to also multiply the top by an a. So this, I want this to become 4a squared on the bottom, so I'm going to make it 4a squared, but that means I also had to have an a on top. So I multiplied the top and bottom by actually 4a, not just 4. Okay, so now I know my denominator is 4a squared. That's a bit better. And I also know that instead of just minus 4c, I'm going to have minus 4ac. Now that's a mouthful, but just hang in there. So, just to point out where the 4ac comes from, look above here. I got a, I got minus 4, and I got c. So I get minus 4ac. Now, what I'm going to do is, I've also got this thing on the right-hand side which is still squared. So I'm going to square root both sides. So square root that side, and I get plus, minus. And on this side, I'm going to have x plus b over 2a. And that's because I've square rooted both sides. Now, we're almost done. If I take this idea, and I start with my x, I'm going to move the b plus b over 2a to the other side. So, x plus b over 2a, if it comes to the other side, it becomes what? It was a plus, it's going to become a minus b over 2a. And then what's more, I'm going to have, next to that, a plus minus. Now what's in here? Let's think about it. So can't I perhaps simplify this somewhat? So I have got that. So actually those are the answers to any quadratic equation, but it still needs to be simplified a little bit. So I want to suggest that we can apply some of the stuff. We can talk about the top isn't a square root, but I know the bottom is. So can't I actually take that out and go, look, I know this is plus minus still, but the square root can actually just be on the top number. Oh, not plus, it's going to be a minus. So this is going to be still a minus 4ac. And over here on the bottom, I'm going to have 2a. Now that's super convenient because my denominator is also 2a on the other fraction. So now the last step is that we're going to say that x is equal to, and I'm going to put the two fractions together. I'm going to go minus b plus minus the square root of b squared minus 4ac. And what's it going to be all over? What's the common denominator? It's going to be 2a. Now, what a mouthful. So, what is the cleverness of all this? Well, we're going to do the next video is going to cover actual examples of how we use this. But the basic idea is, I started off my journey, and boy was it a long journey. I started off my journey right over here with the standard form of any quadratic, which was ax squared plus bx plus c. I went through a series of steps, and I know it looks like, genius scribble here, but basically at the end, I'd used completely legal mathematics, and I now have a way of getting my roots in terms of the constant terms, or the constants at the beginning. All I go is minus whatever b was, plus or minus of that. Now, I want to focus on the plus or minus quickly. There are actually two possible answers to this equation, but that makes sense to us because it's a quadratic. It should have two answers. So how do we find the answers? Well, we simply just use plus the square root of whatever it is, and then on the other root we use minus the square root of whatever it is. Now this will become clearer in the next video, but this really is a remarkable achievement, the fact that we can solve any quadratic. We don't actually have to use sort of haphazard factorizing and guessing and stuff. There's a definitive mathematical way to find the roots of any quadratic. Okay, we'll call it a day for this video now.